Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Rocket Monday, we're gonna talk about SpaceX plans. So let's dive right into it. Now, first thing we have to understand what is their exact aim, what they are trying to achieve. At this point in time, they want to reach orbital heights before 2022. So, aka this year itself, before this year is over, they want to have the accomplishment of actually achieving orbital heights, not orbit, orbital height. So, it will be basically their upcoming test will be more similar to a ICBM test rather than a satellite launch vehicle system. So, what they have to do is basically perform a takeoff. Now, takeoff at this point in time, if you think like SpaceX can easily do that, heck, even SpaceX themselves think they can do that. So that's why they're trying to test the booster and basically booster on a complete load at the same time. So takeoff will be tested. Then they have to do what we call re-entry, the most difficult part of the system. Now, they're not gonna land it. Basically, they're not going to land it on land or any drone ship where they can recover it. So these landings are very similar to when basically Falcon 9 boosters were tested in the first go. Like they were just landing on the sea just to make sure like how the computer is controlling the algorithm, what is their velocity. Basically, it is a data gathering mission. So at that point in time, do not expect it to actually go there and land back safely. It's not going to happen. Like safely in this case will simply mean it will did what they were expecting it to do. So if their computers were suggesting like it should touch on down, basically touch the ocean surface at like let's say 5 kilometer per hour, and if it does that, awesome. If it's like no, it hit like 70 or 80 kilometer per hour, that means there was some issue. So landing on sea, non-recoverable, and this will be their first test of the booster. Now booster, it's huge, as in this is the first time after very long time we're gonna achieve a scale which will actually dwarf Saturn V. So let that sink in. Saturn V was huge, as in Statue of Liberty kind of huge, and this puppy will actually match the scale. And I'm not talking about in terms of just physical scale. I'm also talking about in terms of thrust. So this puppy is huge. And then we come to the most difficult aspect is their actual test of the heat shield. Now heat shield, you have to understand, heat shield was the very expensive component of basically space shuttle. Now you may be like, why were they using some magical material? Not really. So then why the heck it was so expensive? Because each piece was custom built. Basically there was not like, okay, order 10,000 pieces. It was like order a whole back plane which will be cut into this many segments and get each segment. And if during mission they damaged one or two segments, they had to physically order that segment itself. So basically each tile on a space shuttle was unique. That's it. Like there was no copy. And that's why SpaceX is going on this hexagon design. The idea with this will be mass produced. They're gonna just order like, hey, give us 10,000 basically heat tiles. That's it. They're not gonna be like fine tune. Okay, this heat shield only goes here, which was the biggest issue with space shuttle. Now you may be thinking like, okay, if the system works, then why the heck space shuttle was doing with something that convoluted? Reality is having this hexagon may work out, but right now it has a very serious risk of that the moment it enters the plasma stream, the plasma can simply leak into it. Now of course the most of the plasma will not make it through, but enough can leak it into through that it could damage the system. So right now this will be the first time it will be tested. That's why they have to achieve orbital height and almost orbital velocity so they can fall at full force to test this puppy. So this is one thing. And another aspect is which is working on the favor of SpaceX side. The chassis is kind of steel based, so it can absorb a bit more heat. So even if little bit of plasma goes through the gap, it will not instantaneously compromise the structure. So they're hoping that this puppy is good enough. So far they have tested the physical attributes, so it's not gonna fall off, which was like a ironic mistake which happened with space shuttle. They were like, oh, the heat shields are super awesome. They tested it from a jumbo jet and it's like most of the tiles fall off. It was that bad. So they are making sure they learn from the history that like make sure the physical thing is intact first, then test the thermal properties. So we're good. Then we come to the pipeline as well. It's like how they are making things progress, everything. At this point in time, SpaceX is not sharing much information, and which is kind of for better, because like if you follow Elon Musk Twitter, you will get crazy simply because it's like SN15 will launch again, and no, it's not gonna do that. So we're gonna do this, and no. So be mindful at this point in time. SpaceX is not sharing too much information, so everything is take it with a truck of salt. Another aspect is plants are too dynamic. To give you a context of that, at any basically rocket manufacturing facility, any on the planet, you're never gonna change the design in such a way that's like, okay, we design the center of gravity based on the fact that methane tank would be on top or on bottom, like whatever have you. Like I think in case of Saturn V, the kerosene tank was on top in the booster stage, or oxygen tank, whatever. Like just assume that was designed, and they're never gonna change that. They're like, we're gonna build this damn thing. We did all the research we can do in the design phase, so we're not gonna change it. SpaceX is like, yeah, we think we can switch it up, you know. So even after even if they actually started manufacturing the goddamn thing, they may be like, you know what, our current understanding suggests that this will not work, so they can scrap it. So plans are too dynamic, so be mindful. That's why you will see okay, SN9, SN10, SN11, and SN12, and what the heck happened to after that? It's like SN15 directly happened. So be mindful. That's why they could happen in a scenario where it's like they build the booster number one and they're like, you know what, we can switch the propellant tanks. They could do that and scrap the whole one. So this does give them a lot of experience in terms of rapid manufacturing, but does come with a cost of being bit wasteful. And their current aim is having up to 32 engines on the booster. Now you may be like, isn't that higher than the last one? Absolutely. Wouldn't that drain fuel faster? Absolutely. That's a desirable effect. Think of it this way, like if your fuel tank is fixed, like let's say you have 100 tons of fuel, that's it, that's all you're gonna get. 100 ton, do whatever you have to do with that. The faster you burn it, the further you can go. So that's basically improves your efficiency in one way. So if you have more engines and you can burn through that propellant very quickly, that will actually give you more margin, so to say. And that's what Elon Musk was talking about, like having 32 engine will give them better boost back return. Basically they will not burn through 100% of the fuel, and during return they will have more fuel to do fine control. So that's a desirable thing. And they will have 6 engines on Starship. So right now they have only tested up to 3 engines, and their vacuum optimized engines should not be tested on a C stand, but you would have seen that like, they're actually testing the vacuum nozzle. Why the heck it's not blowing apart? Simply because it's reinforced. It's almost same as space shuttle engine nozzle. Space shuttle nozzle was the one of the only time I know that engine was like ignited on sea level and actually went up to space. So that's the reason you can design a nozzle that can like have a, you know, basically optimized for vacuum and fire in sea level without any boom events. But it does make your nozzle big, heavy, and bit more expensive. So their aim right now could change very drastically. That's why like their pipeline is bit too dynamic. Do not for the, oh, they said this, so this will happen. No, they could literally do everything. They could even file paperwork and they're like, you know what, I don't think this is gonna work out. That could happen. So be mindful, relax about it. Their pipeline is too dynamic. Then we come to the spicy part of things. They got suspended. NASA is like, no. So what happened? Basically, NASA went to Congress and we're like, okay, we want upwards of, let's just say, $10 billion for Artemis mission. Government was like, launched the Artemis directive. NASA is like, okay, give us $10 billion. Now, while this is happening, while NASA like actually gave the request and Congress is processing, NASA went to these 3 competitors. Actually, they went to multiple competitors and they were like, okay, please give us suggestions what we want, you know, basically bidding war. And in that bidding war, they lined out a budget. They lined out other things like we will always have 2. So do not be like, okay, you only selected 1. No, they will have 2. That was like from day 1. And the 3 contenders that were like, you know, finalists, so to say, was Dynetics, SpaceX, and National Team, which many people are now calling Blue Origin basically. So these two were the, basically everybody was expecting Dynetics and National Team to win, not SpaceX, simply because Dynetics and National Team, they are relying on SLS, which is already built, already done. Like everything about SLS is done. It's like in final preparation, so to say. So everybody was expecting these 2 to happen because again, SLS is much further along in its development compared to Starship. So the idea was that there's supposed to be 2 people, and these 2 were the likely candidates simply because these will just plonk on top of SLS. However, NASA chose SpaceX. Now this happened primarily because Congress was like, hey bro, we cannot give you 10 billion. How about 3? How about 3? Are you happy with 3? So NASA was like, what the hell? We can only support SpaceX because that's the cheapest option. So they did that. Now National Team filed a complaint. Now you'll be like, how can you file a complaint against NASA? Well, there is a department known as Government Accountability Office. It's actually a good thing. I do like that. And be mindful, SpaceX was the one who filed this sort of claim in past against Air Force because they were not allowed to bid in the basically satellite launch market. So be mindful. It's a good thing that we have something like this. It's a very good thing. Then we come to actual crux of the situation. There must be 2 systems. Under no circumstances NASA will like to have 1 system alone, no matter how good that is, because remember that's the exact same thing happened with space shuttle. And that's why when even Dragon capsule was built, they still funded the development of Dreamliner from Boeing side, because they wanted to make sure under no circumstances you should have only 1 vehicle. Must have multiple vehicle, multiple options. Now of course multiple option will cost too much, so they are not, let's tone down to 2. 1 is unacceptable, because be mindful, what is the things that are similar to basically Starship and basically Saturn, basically space shuttle. None of them have escape system. So if there was an issue, they could go boom very quickly, very without any warning, and poof, things can go bad. Or you could have a scenario where it's like you landed the system and then micrometeorite punched a hole into it. Things can happen. This is a big structure, so probability of getting hit is much higher. The larger your structure, the more probability you have of having a hit. The longer you stay, that also gets multiplied. So you can have everything done fine. Heck, SpaceX could do amazing job, and one bad rock is like, today's the day SpaceX gets grounded. Things can happen, and that point in time you will be like, I really wish I had a second option. So there, from a safety point of view and redundancy point of view, you must have two options. Under no circumstances you want only one option, because we never know what are the faults on in a system unless you have used it for long enough time. So you could have like, I did the testing, I did the test mission, everything would be awesome. Remember, we have jumbo jets that had to be grounded after they were in service. After they've been in service, they did cleared all the customs, all the tests, everything. Then we had to ground them. It happens in rockets also. Be mindful. Basically, Soyuz also had an accident recently, which they had to ground the whole fleet. At that point in time, ISS was stuck. They had no way of resupplying it. So be mindful. You always have to. Under no circumstances, one is flat out no go. Now, what can NASA do at this point in time if government does not basically increase the mandate, and government accountability office is like, bro, you have to have second competitor? They can simply say, okay, government, shut up and kill the lunar gateway. Now, nobody wants to actually do the lunar gateway. It's a bad idea from every standpoint of view. It's actually bad for the health of the astronauts. How bad? 50% more bad compared to landing on the moon. Now you're like, how the heck it can be worse than landing on the moon? Think of it this way: when you are on moon, and if you take a celestial sphere and assume every point in that celestial sphere you have radiation coming in, which just happens in deep space. But what happens when you are on the moon? You have a huge ass moon below you, and that is acting as a very good shield against radiation. So 50% of radiation is flat out blocked, and that will happen even if you are landed on the dark side of the moon. Solar radiation cannot reach you. So flat out, it's much better from radiation standpoint of view. And then if you actually land there, you can reinforce the radiation shielding. You can have feet thick, like a heck meters thick, basically lunar regolith, making a shield where it's like, no, now the radiation, background radiation level on this base is lower than default situation. So lunar lunar base is awesome. Lunar gateway is a bad idea. Now you may be like, okay, it's a bad idea. Astronauts don't want to do the mission planner, don't want to do it, NASA don't want to do it. Then why the heck they're being built? Well, politics. Now, if you want to understand the politics, is the problem is ISS will be retired very soon at this point in time, and that's the issue. ISS was an international collaboration. However, even in that sort of scenario, it only had two horses in the race, aka Russia and USA. Everybody else, including basically Japan, European Union, Canada, all these are like subsidiary. Basically, they are helping along, but they are not the core backbone of it. Now, because of the request of USA, China was not allowed into ISS. Now, if ISS is retired and there is no next project, quote unquote, where you can combine all these people, China will be like, hey, come to us, I have a space station, come to us. Like, and China is building their space station, like second space station, I think second or third at this point in time, which would be really big, really good. And again, currently built technology, it will be much better than ISS. So if China starts to gather up support from Russia and European Union, that would be really bad for USA. So USA wants a project that will bind all the basically Western worlds together. They can still do that with basically lunar base, and it would be much bigger project than outdated space station project. So I really don't get it, but politics. So we have to understand about fairing recovery. This was a big news recently, is that SpaceX wanted to save fairing from salt water. They had figured out fairing recovery very early on. It's like they will have paragliders on that, and because fairings is surprisingly light, again, it's just a cover. It's surprisingly light, surprisingly large surface area, is really controllable during re-entry. So that's why even though it's re-entering in orbital velocity, it's not burning up. So it does work. But problem is, if you want to reuse this, you ideally do not want to touch have any contact with salt water. Salt water is idiotically corrosive, so people really do not want salt water on anything near to a satellite. So they wanted to do that, and they built a giant boats for that, two boats for this. Now the boat costed a lot of money and took a lot of considerable amount of efforts and all that. However, it failed horribly, as in it had worse basically record than their booster landing record, so to say. So it failed many failed attempts. However, one of the time they were like, okay, we have captured the fairing. Fairing has basically all the sound insulation foam is gone because of the salty water. What if we do not use that? Now you're like, wouldn't you want sound insulation on your satellite launcher? No, Starlink was built in exact this way too, so it does not require basically sound insulation. You can look at the launch, and why they did that? Just to save some kilograms, and that I think it's like what, 4 extra satellites they can pack if they remove the weight of it. So they are going for packing efficient. Satellites are built so robustly that it does not need that kind of insulation. So they're like, okay, we have a scenario where we have recovered this. They did all the testing. They're like, at least we think this should work even if it has touched seawater. So they flew a Starlink mission. Everything worked out, and then they realized, hey, every time somebody comes along to us like, hey, can you launch this puppy for us, we're gonna give them offer. Hey, you can have cheap reused basically payload cover. If you're not okay with that, no problem, we're gonna design a new payload fairing, and you're gonna be happy with it. And once you are done with that fairing, we're gonna reuse this puppy with Starlink, because we're gonna have hundreds and hundreds and hundreds of launches with Starlink. So we from their point of view, SpaceX point of view, it's much more efficient to bypass these two boards, because again, these boards are expensive to run. So they flat out realize that Starlink is an in-house system. They do not have to have, like, meetings, committee meetings, blah blah blah. It's like, dude, do it. So they realize that flat out they do not need to convince anyone. They can just land it on the sea, recover it easily, and everybody would be happy. Now we come to another catching part of it, that is booster catcher. Now booster catcher is catching a lot of headline. A lot of YouTubers are making some amazing 3D renders of, like, how booster is gonna, and somebody is, like, actually launching from a cradle and then, like, playing the video in reverse to show that how we will land this puppy. Now the idea is new, very new. Fundamentally speaking, the benefit of that would be booster would be much lighter. Legs are significant structural equipment, so they will be big and heavy and jungles. So removing them does eliminate the weight, significant amount of that. Now you may be like, how will you capture this puppy? Well, only the strongest part in a rocket is the thrust puck, basically where you have the GG amount of thrust being mated with the chassis of the system. This is the strongest part. But what is the second strongest part? That's in case of SpaceX systems, that's basically grid fin. So they are like, grid fin is already built to handle severe amount of stress during re-entry. Again, this is not orbital re-entry, but still hot enough re-entry. So they are strong enough, they are mechanically strong enough. What if we utilize that point of view to catch it? Now that's the idea at this point in time. Now in this scenario, every analysis they have is like, the launch tower is the easiest thing to build, because we have to build launch tower. It has to be big enough to do everything, so why not just add the catcher system onto that? However they're gonna do that, that's unclear at this point in time, and I'm not even sure they're gonna actually do that. That's why I shared the story of, like, trying to catch basically fairings and then scrapping the idea. It's too convoluted. So can this be done? Yes, physics is not saying that you cannot do that, but this is a high risk system because you have multiple points of limitation. Okay, first limitation, let's say your basically launch pad is occupied with something else, because SpaceX is planning to have multiple launches, and if they want to do orbital refueling, they have to do it. Like, they do not have the luxuries like, okay, we're gonna wait for 7 days or 8 days. No, you have to launch it as quickly as possible, otherwise most of your fuel will evaporate. So they have to do that. So what happens, let's say for some reason, some technical fault happens on the rocket that was on the pad, it malfunctions and they had to drain it. This launch pad would be out of commission. In that time, the booster that is landing, where the heck would you land it? You can't land it on any barge ship. Even if you can build a big enough barge ship, the likelihood of building a giant crane like structure that can capture it mid-air, good luck with that. So fundamentally that limits them. And you could also have other scenarios, like, let's say some fault happened in the booster. For a fact the booster is on fire, and if it lands there, even if it's completely intactly landed, it will blow up soon, which has happened with SN prototypes. Again, you would not want to risk your main tower. If it has landing link, you can land it anywhere. You can land it, heck, you can have a scenario as like, just dude, land it here. This place was specifically built to handle fires. You could have, like, the moment it starts to land, you will have, like, let's say 5 or 10 fire hydrants firing at it, like, to quickly cool it down. So that's the whole point. So they're giving a flexibility, which is a very big element if you want to do rapid reusability. So I'm not very keen on that. Could they do this? Yes. Could they scrap this after they have built it, after they have used it? That's why I shared the story of, like, trying to capture the fairing system. Many times economics do not line up. So in this scenario, my assumption, my opinion is, this puppy is not a good idea. It's like, yes, can this work? Yes, but again, compared to thrust puck versus basically thrust puck versus grid fins, I will put my money on thrust puck to be able to hold everything, because this puppy is designed to handle a heavyweight system. This On the other hand, basically Griffin, it only works when the rocket is mostly empty. So it's like it's barely designed to handle 20% of the weight of the rocket, while the thrust buck maximum loading. So like my inner gut says like they will try the system, but they might not use it in long term. I could be wrong, but let's see. So this was my presentation on SpaceX upcoming plans. Hopefully you have liked this, learn from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me extra disappointment. Please leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.